introducing myself. I'm out of the Bay Area. I live over in Oakland. Flew all the way into the fine state of Kentucky here. And during my day job, I guess I do a lot of like web app pen tests, security assessment, source code review, that type of thing. And yeah, I work for independent security evaluators. So that's there's some really cool folks doing some interesting security assessments. And you know, some of the way that I kind of got into this was I got interested in the So Hopelessly Broken competition at DerbyCon a couple years ago. And that kind of got me interested into some of the hardware space and digging into that a little bit more. And it's been fun to kind of build on that experience. And that's kind of like where I got started with some of the the router hacking stuff and moved on to more like home automation type stuff. Yes. 2 minutes. Well, I'll hold off for one more second. But, okay, yeah, I'm just going to go for it. So, you are in practical hardware attacks against SOHO routers and IoT devices. I wanted to kind of put this together as a talk geared at giving people that are new to hardware hacking, like, you know, a place to get started, you know, like a way to kind of get into this. Because when I first started doing hardware hacking stuff, I was completely like a software guy, had no idea about, you know, the physics of it or even how to use a multimeter. So I had to start there and start working forward from that point. So yeah, this is just a little bit about ISE. We're all over the place. I mean, we kind of hit up some of the various cons here, but yeah, hackers, cryptographers, reverse engineers. There was a bunch of research that was done that kind of founded the company was around some of the like Ford immobilizer. Hacking some of that stuff, and then obviously some of the iPhone and Android hacks. Jacob Holcomb is one of our guys as well, and he was doing some of the router hacking and NAS stuff a couple years ago that was kind of really helpful to be able to watch some of his stuff and get interested in that. So I guess I kind of talked a little bit about who I am, but yeah, I'm Schultz. I'm a senior security consultant. That's my Twitter handle, and it's at the end of the talk too, so if you want to grab it, you can. But yeah, those are some of my interests: reverse engineering and hardware, software-defined radio stuff, fuzzing, and then, you know, kind of getting into the embedded systems space has been a really good experience as well. So. Okay, so this is pretty much what I'm going to be talking today about. We're going to kind of go through these items here. We're going to talk a little bit about the hardware hacking and some of the tools of the trade, a little bit into some of the methodologies that I've kind of acquired through working and playing around with some of this stuff. And I've got lots of pictures. So if I speed through it, we'll go to photojournal or whatever have you. And then I've got a demo for you guys today just to kind of solidify. I think that always helps, is to be able to see, you know, what some of these like hardware interfaces and what you can do with them. So I've got a little home automation device down here that I'll power on, and I'll walk through the UART interface on it, and, you know, what it looks like just seeing a device boot up, that type of thing. So I kind of got into all of this, like I said, with the router hacking competition at DerbyCon a couple of years ago, and I really like that. And then now, you know, there's all this like IoT space stuff, and I mean, there's all of these devices. I think IoT is just like another rebranding of machine-to-machine communication, and all this stuff has been around for a lot, for quite a while. But I think it's now getting to the point where there's all these toys and little devices, and now we're supposed to have like billions of connected devices in the next before 2020. Yeah, I got into this hardware hacking thing, and it was kind of an interesting time. I was doing like lots of web app stuff, Windows reversing, applications, security type stuff, and then I decided, you know what, I'm going to learn some stuff about hardware. And so I decided, let's take the software guy back to school. And so the reason that I got into the hardware hacking stuff is these are like little black boxes. They run Linux, they do things, but you like trying to pull up like a terminal on them or something like that. You just can't get to it without like playing around with some of the hardware stuff. So it's a great way to get into a device for initial research. So going through like these UART interfaces or playing around with some like JTAG stuff for debugging, it's they're really kind of entry like points to get in there and kind of start looking at pulling off the binaries or dumping the flash memory, and so yeah, we kind of talked about some of the IoT space, but yeah, the like smart homes, medical devices, toys, health fitness stuff. I mean, Fitbit, obviously. Lots of sensors out there for like your house, like the I don't know. I've got a couple of sensors at home that are like doors or like home security type stuff, motion sensors. All sorts of devices that are hooked up via Zigbee and Z-Wave. So when I kind of started first thinking about like hardware hacking, I didn't really know what it was. These are like some of the terms that kind of I at least associate with hardware hacking. So there's UART, or Universal Asynchronous Receive and Transmit, and it's basically a wireline protocol or serial protocol, if you will, that you can access, and it's basically like a terminal or like a shell access. There's about like 4 little pins, and there's a receive and transmit pin, a ground pin, and a VCC pin, which is like voltage for the most part, and then also JTAG, which I think has a lot of kind of misconceptions of what it is. I mean, JTAG, you probably heard of it from like Xbox hacking or something like that, being able to do that. But it's really like a hardware kind of debug interface so that you can run like a debugger and do hardware breakpoints, stuff like that. And then finally, SPI and I2C are basically the kind of like wireline protocol in between 2 different components or chips on a board. So you'll have, like the main application processor, and then there'll be, like a SPI interface for like the flash chip that it'll hook up to through the traces on the board. And so these are kind of the first things that I associated with hardware hacking. Just to kind of think about it that way. So this is what is this? Oh, this is a camera and home automation device, or like home automation hub. And so you can connect other Zigbee and Z-Wave connected devices to it. But when I first was messing around with this, I like popped this thing open, and it's like trying to put the batteries in, and I look at it, and there's like little cutout in the back with these like 4 pins exposed there. So I was like, all right, wonder if I can play around with this. So the device, the Piper NV is the thing on the right there, and then the little board that's attached to it is a device called a Shipra, and it's made by Zibiter. So Stephen Ridley, if you haven't seen any of his stuff, he really excellent resource for like hardware hacking. He gave a talk a couple of years ago. Was it hardware hacking for software people, I think. So definitely check that out if you get a chance. He kind of, when I took his course this last year, he said that he kind of just like made it because he wanted one device to kind of rule them all, if you will. So it handles both UART, JTAG, and also as a SPI interface if you want to do things like dumping flash memory or wiring up to these boards to try and pop a shell, and also, you know, as a JTAG interface with OpenOCD. So, kind of like tools of the trade that, you know, when I started like building a small lab at home, it's definitely nothing as professional as like IOActive's lab or some of the like hardcore hardware hacking folks. You know, I'm just another guy trying to play around with some stuff. So, you know, this is a picture of you know, my desk at home with multimeter and a couple of routers hanging out there and some tools to try and, you know, kind of get in devices. This is you know, just another picture of another lab bench that I have set up at the house, and it's got like a pile of routers there. It's a pile of ponage, as I like to call it. But the you know, for a while I would just, you know, buy one or two of these routers at a time, and I'd be like, well, let's just go see what's on them. And for the most part, I, you know, tried to stick to pretty like cheap ones that, you know, some average consumer walking into Best Buy, you know, what are they gonna buy right off the shelf? And so like most of these are like, I don't know, $20 to $40, maybe 50 tops. And, you know, popping them open and starting to geek out at the hardware and trying to figure out, you know, what type of stuff is on them, identifying like the various interfaces and stuff like that. So this is one of the first like absolutely, you could probably get by without it, but like they're so helpful. Like having a multimeter is like really helpful. This is like I think a Fluke multimeter, and it can do like continuity testing is the main thing that I use it for. That and like monitoring or like probing around for various voltage, trying to figure out like what the pins are, you know, what type of system I'm dealing with, and stuff like that. It's really useful. I use it for like pinout reversing. So I'll sit there and I'll try to find like ground first. You know, that way I know I've got like a place that is grounded on the board, and I know that you know, if I want to like try and mess with some stuff, or if like a reset pin to ground to like halt the device, that type of thing. And then the next thing I'll use the multimeter for is like on the voltage setting, to be able to look at voltages as the device is starting up. If I can find like a TX pin sitting on the board, and when you plug it in, you'll see like fluctuations. It'll be like at 3.3 volts and it'll drop back and forth, and that's usually like, you know, 1 bit, 1 0 1 0 1 0, and you'll see that voltage. Like it's funny because it's like an actual physical representation of, you know, what I know are probably like some sort of data going across a particular line. So this is another tool. This is like this is the Shikra again. Got a good picture of it. The link down there is int3. Their website there is awesome. They have lots of cool tools for hardware hackers. I think that they have like the Shikra here. I think they also have the Face Dancer from Travis Goodspeed, and a couple other like devices. But yeah, the awesome place and pretty freaking awesome device. I have noticed some limitations with it. So like this is just one interface if I wanted to do UART stuff. There's also like a bus pirate or bus blaster, and then your various different dongles for JTAG and stuff like that. But I do like this device because it can do multiple different things. One of the limitations that I finally ran into recently with the Shikra is it's mainly for 3.3 volts. So if you get on a system I was looking at another home automation hub thing, and it was 1.8 volts, and I was like, oh crap, I can't hook anything up to this. So I was lucky to have another tool in my my tool set that would do it, but as far as a JTAG interface, I was kind of shit out of luck. So here's another awesome tool. Joe Grand made the JTAGulator a couple of years ago. It's really one of the best tools as far as trying to reverse the pinout. It will brute force a pinout for you. So say you solder onto a board and you don't know which pins are what, you can just wire up to them, and he made it so that it's you can have different voltages on it and it won't mess up a board. And I mean, if you're interested in some more of that, go check out Joe's talk. He goes way into depth about it. But I've really enjoyed this, and it's useful for both UART and JTAG, obviously, to try and figure out the various pins. And it can also act as a pass-through and a couple other things. So obviously, if you're going to do some stuff with hardware, a soldering iron, pretty useful. This is just one from SparkFun, I think. But yeah, totally useful for just, soldering on the pins that you might find and identify on there. This is some headers and some jumper wire. So when I'm wiring up to a board, this is definitely in use. This is a picture of a SOHO logic analyzer. This is really great if you have some data going on the board and you don't know what it is or how it works. You can hook up some probes onto the board, and in the SOHO logic program or whatever. And I've got some more slides about this later. But it can do some protocol analysis for you and things like that. And you can find that at SOHO.com. So this is kind of the methodology that I usually take when I get into a device. So basically, I'll try and pop it open. There's lots of plastic and stupid little security screws. Having a nice set of screwdriver heads and that sort of thing is a good thing to have. The iFixit kit is great, the 54-bit drivers to pop open some of these things. And then, once I'm actually in the device, looking around at the hardware, post voiding my warranty and joining the exploitation party, I will get in there and try to identify the various components and chips. And that's pretty easy because they have little, I don't know, little bits of text of some code or whatever, and you can pop it into the internet. And figure out what the actual chips are, that type of thing. Go find the data sheets for it. Data sheets for chips will tell you a lot about the various functionality you might find on a particular device, and it's one of the best ways to kind of actually know what all a chip can do. And then I'll kind of just peruse around the hardware looking for unpopulated pinouts or unpopulated pads, that type of thing. And then I'll solder some headers onto it and try and figure out what's going on there, and do some continuity testing like I was talking about, where the finding the ground pin, and then looking for the TX pin, that sort of thing, with the pinout reversing. Identifying the wireline protocol logic, so that's where the SOHO logic analyzer comes in, super useful there. And then, just wiring up to the board, device interrogation, firmware reverse engineering, if I can dump the flash from the device or grab the firmware from, a network dump as it's updating, something like that. And then, I'll get into the depths of kind of the security research. Once I'm able to pull off some binaries, I'll toss it in IDA, start reversing, or, I'm one of the things that I really want to work on next is kind of like a evolutionary feedback fuzzer for ARM and MIPS devices, but that's something that I'm totally into. So, first step, void some warranties. Pop open your boxes, find your devices. That's the Smart Things. That's the Piper there. The Wink Hub, which was a pretty interesting one. And then, yeah, that's just like right over the screw that gets you actually into the device. Read your data sheets. They definitely are useful. So like this one is from a flash chip. I was trying to dump it on the Smart Things hub, and I mean, I finally did dump it, but when I finally got the firmware off of there, it was complete junk. I don't know what it was. It's probably encrypted and needed to do some more reversing on it. But this is great because you can find like the various pins that you need to hook up to when you do like a SPI flash dump with flash ROM. And then, yeah, just another picture there. So as far as like identifying various like hardware interfaces on a board, this is a picture of a UART interface on a, I think this is a TrendNet maybe, I don't know. But yeah, so this is UART, and like I said, the 4 typical pins: ground, VCC, RX, TX, all right there. This is a JTAG interface on a Belkin router before I soldered some headers onto it. And it's really nice when, so like this is another one, and this is like a surface mount JTAG interface, or like serial wire debugging interface. And the Wink Hub is like a really good example. Most of the stuff that I popped up, and they don't like label it as awesomely as like Wink did. So like the UART interface is like very nicely labeled. The JTAG for this chip, and they're all just like laid out as discrete units, and you can kind of see it there. The Wink Hub also has like a number of radios, like Zigbee, Z-Wave, Lutron, some other weird one I had never heard of. So as far as like the pinout reversing, this is kind of how I go about it. Before, I just started using like the JTagulator to just figure it out, going in there blind. Solder on some of the headers here. This is just me doing a little bit of soldering. Pretty terrible at soldering, but I'm good enough to get it into the device. Drew over there's cracking up. He's seen my solder. Yeah, and so then, this is like a picture of hooking up to like a ground, like probing for a ground pin. Usually I'll try and find like an Ethernet jack, or, if they've got some covers over it. I will do like a continuity test first, and then try and find the TX pin and go through that one by one. And so this is a picture of the Soleil logic analyzer, like hooked up to what is this device? Oh, this is, yeah, I'm not ready to name this particular device, but it's the one that's down here that I'll show you guys here in a little bit. And the Soleil logic analyzer is, like I said, really good for trying to figure out what's going on a particular chip or interface at a given time. And it has just a couple of probes that go out. You hook up like the ground pin to make sure that you're not going to fry your device when you hook up to it. That part's pretty important. And then yeah, so you hook it up, and then there's like, all the various pins or things that you would want to try and see what's going on. The Soleil that I have here, I think can do like 8 channels at a time. The little smaller one there's a $50 Soleil logic analyzer, I think, you can do 4 channels at a time. And so it's useful when you just kind of want to figure out, what's going on, what the the bits flying across things are. And here is, can you guys see that? Okay, so this is the Soleil logic program, and what it does is you'll see like the high-low, 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 and what I did here is I figured out that this was the TX pin, and I applied one of the protocol analyzers to it, and this is the asynchronous receive and transmit one. And what it'll actually do is it'll show you like the letters and what they stand for, that type of thing, and the actual logic on there. So some playing around with like UART and that sort of thing. So here I've got it hooked up to a TrendNet router. The Shikra is hooked up there, and then like the little yellow sticker was not there. That's me after the fact. Usually what I do after I've figured out the pinout and stuff like that, then the next step is to like wire up to the board and try and figure out what the baud rate is. So with UART, there's a baud rate that's associated with the particular interface. Most common is like 5200 that I'll find, but there's various different baud rates on some of the devices, so that is useful to try and like figure out. And there's a really cool, couple of scripts I think that like Craig Hefner wrote, like baud rate.py. And once you're wired up to your board, you can just see it. It'll just go through various different baud rates, and you can see like it'll either be text or junk. And I've gotten junk a lot, and then I'll switch to a different baud rate, and then finally it comes through. So yeah, the picture that just came up is another. That's a TP-Link router that had a UART interface onto it. And it's funny with some of these, like pretty much all of the home routers that I looked at, you just wire it up to them and it drops you straight to a root shell. It's like no password, nothing like that. Like, so with the TP-Link, there was an actual password, but it turns out like somebody had already figured it out on the internet for me. And so when I finally did check it out, and grab the hash by reverse engineering the firmware binaries with like binwalk and that sort of thing, I pulled open the Etsy shadow file. I just tossed the hash into Google just to see somebody may have hacked it and or cracked it. And it turns out, yeah, sure enough, it was like posted on an unrelated, it was a related TP-Link product, but it looks like they're reusing their passwords across multiple things. Anyway, the password was SOHO admin, all lower text. So it wasn't too hard, I guess. But so a lot of them are just like they'll drop you in. Sometimes there's a password on the interface. Totally depends. Here's like 4 or 5 of the various devices. So I've got stuff with D-Link and Belkin and TrendNet and a whole bunch of them. There's a couple of Netgears there, and I've got like a list of them there. So like I said, these are just like the various pins that you want to look for. Baud rate, got to figure that out. This is the pinout for the Shikra. So one of the things that didn't make sense to me, like when I first started playing around with this, was that, I'm just going to wire the RX pin to the RX pin on the board, but it's actually the other way around. So you have to do you do TX to RX and RX to TX, and then that way, it will. It makes more sense that way actually when you kind of think about it. That way you have like the transmitting device and the receiving device, and there's no kind of like crossover there. So this is one of the documentation that comes with the Shikra, but you can see here it does UART, the JTAG and SPY, and it's got like the, where all the pins are and everything like that. So that's definitely useful. So when you get your Shikra or Bus Pirate or JTagulator or whatever, most of the time when I'm interfacing with one of these like cards or dongles or whatever, they're usually through screen. So you'll run screen, and then you'll have the particular like device that pops up in your under /dev, and then finally the like baud rate, and then that'll drop you in. And so I have a demo here in a little bit. I should probably get moving towards. But yeah, here's another instance of the Wink Hub. The Wink Hub was pretty cool. XenoFX came out with this kind of ingenuitive way of bumping the router. So like with the Wink Hub, when you would boot it up, it wasn't just so kind to just drop you off at a shell. You'd see the whole boot and everything like that, and then it would just sit there. You couldn't like Control X or Control C to try and break out or anything like that. So what he actually figured out was that you could take and the flash chip that was sitting on the board, at the right time during boot up, you could ground that pin, the read pin on the flash chip, and it would basically fail over to the bootloader. So you couldn't get to the bootloader but just by like mashing a key, like some of the devices, like I'll show you here in a little bit. But by messing up the read from the flash memory, it dropped them off at the bootloader, and then from there was able to modify the init parameters. Yep. Yeah. So, I've seen, like, you'll see, like, press any key to go to the U-boot bootloader. Right. Right. I think so. I think that's why it failed over. Then I had never seen it before. I thought it was kind of cool. It was kind of hard to like get right down on the pin at the right time. But yeah, I think that's probably definitely a feature of U-boot. So yeah, this one was kind of cool. So here's like a list of the various devices that I've been playing around with, whether they have like the UART access or JTAG access. I've also gone through and downloaded the firmware for them, walked them with like binwalk, and then looked at the various like password files or like binaries or programs that are running on the devices, some of that stuff. So what I'm going to do now is I'm going to go through and go ahead and just show you guys a quick demo of what this looks like, folks. Okay. You see here? All right. So this device I've got down here, and I should be able to power it up. So let's go here. Is that big enough for everybody to see? Do I need to make it bigger? Bigger? All right. Hopefully that'll be a little bit better. Too big? All right, here we go. All right. So here, this is the device as it shows up on like a Mac or whatever. Under Linux, it could be like dev / USB TTY 0 or something like that. So I'm giving it the baud rate that is specific to this device, and I'll start screen. Another thing is with screen that I like to do is I will set like the log on. That way I can get a whole log of my like boot as it goes up. And so now we'll just flip the switch and hopefully everything will run. So here we see it's going ahead and booting up, and we saw the little part for the U-boot bootloader, and it said smash any key if you want to go into the bootloader. So that's definitely an option. And so, and I don't have it hooked up to the internet or anything, or the the Ethernet jack, so it's going to kind of like fail here for a second. yeah, then you'll see like the typical like Linux booting up, right? And it turns out with this device, it's actually running a embedded version of Ubuntu. And so we get to like a particular like the login here, and oh, I don't know what the username and password is, and I can't get to the firmware to just like like pull out the hash from the shadow file and try and crack it or that type of thing. So what I decided to try and do next was to see what that like U-boot thing was. So I'm going to go ahead and like restart the device again, mash the key, and then we get to the U-boot bootloader, and it's got some functionality. I mean, you can kind of like play around in here and see the various different functionality that it has. But one of the ways to get in on some of these devices is to modify the boot parameters of the kernel. And so what I finally figured out was I could do this this command here and edit the arguments for it, and it would give me like what the current environment variables and like the main disk and everything, rootfs, where it was located, that type of stuff. And I just added, let's see, just added this guy. And so basically what I'm telling it here is to, when it does boot, just boot to a shell for me. And so then just run boot here. Booty. That's what I'm after. So yeah, then at this point, it just drops us off at a shell, and I can do like stuff like, and so we can see here it's like a Linux ARM variant. And then at this point, I can start perusing around the device, looking for configuration files or other things that are out there, that type of stuff. So like this is kind of what it looks like when you'll go through the boot process and then get dumped off at a shell, and you have it via like a hardware interface. So I'm just going to turn this off for a second and show you guys what it actually looks like here. So yeah, so this is basically it, and then I've got the Shikra hooked up and wired up to the little ports on here. So that's the demo, and I am cruising, so I might have a little bit extra time here. I should just slow down. Yeah. So yeah, that was kind of cool. We did a little bit of the demo. I'm in the process of doing some responsible disclosure. There are certain things with that device that I am yet to report, so I don't think I named it by name, but we'll get to that. I'll publish the details later, definitely, for sure. So this is the a little bit about JTAG. I haven't had a chance to do too much with like actual JTAG stuff. I just got to do it recently with a another home automation hub that I've been working on, and this is where I found out that on 1.8 volt systems you need like a different interface than the Shikra to actually get on there. And so the JTagulator is really awesome for this stuff. It'll help you find the test data in, test out, the clock, and the mode select. And what JTag will allow you to do is it's basically like a hardware debugger. Oh. Lose it. There we go. Cool. All right, come back here. Okay, so back here. Yeah, so OpenOCD is the, what's that? OpenOCD is the like one of the tools, and it's free and it's open source. It's useful for starting up like a GDB session, and it'll start like a local telnet shell on your local host, and then you can use that to access like GDB and do some of the hardware stuff there. So the JTagulator is awesome for finding the pinout, but as I recently also learned, it's not like a JTag interface. So what I did recently with the project that I'm working on now is actually went online and bought a J-Link adapter and like a breakout board for the little interface that I needed to hook up to, and I'm hoping that'll work. But yeah, just a short little cliff note because I totally screwed me up when I was going through it. The JTagulator will find the pinout, but it will not be the interface. So finally, the last thing that I kind of briefly mentioned, the like dumping flash. So like in the instances, say you're working on a device and you've tried going through the to grab it while it comes down over the wire, but maybe they're doing like certificate pinning or something like that on the device, and you can't man them in the middle the SSL traffic or TLS to like pull it out of the network firmware. So and in that instance, sometimes it's just easier to try and pull it straight off the chip itself. And so this is one of the things that's awesome about the SEX via hex class is, and the thing that I was the most excited about for this class was dumping the software for a device via like physical means like this. And so here what I'm using is just like a Raspberry Pi. I tried to use the Shikra, I really did, but it was coming back with errors and misidentifying the device, and it couldn't do it. So you can definitely use a Raspberry Pi too as like a UART interface and some of the other stuff as well. But I was using it here as a SPI interface and dumped the flash. And so you can see here, I went online, figured out like the particular flash chip, and then like read through the data sheet and found the various pins around the flash chip. And as I was doing this, also one of the things to pay attention to is as you're trying to do this, and say the device is powered and there's communications going back and forth and reading from flash, and you try to go dump memory on it, it might get corrupted. So the way to kind of get around that fact is at least on the smart things, what I found was like a little reset pad, and I grounded the reset to ground, and that held the device in kind of like a halted state where it's powered, and power is flowing to the flash chip, but it's not like reading or writing. So then I was actually able to dump the flash with flash ROM, and that's the little tool to do it. So Flash ROM is a little open source tool. That I'm not sure who wrote it, but it's definitely available online, and you use it to basically there's just like a read flag, and then it dumps it out to a file on your computer. And usually when I do that, what I'll do is I'll do it 2 or 3 times. That way I can see if it is corrupted, and I'll do a hash of it, of the various different ones that I get. And if one of them's off, then I know, I'll keep doing it until I get it right, or change my formula up, that type of thing. So if you're interested in learning more about hardware hacking, I can definitely suggest the SEX via hex class. It's super awesome. Check it out. Zibiter does an amazing job. And it's Stephen Ridley and Joe Fitzpatrick, I think, yeah. And the other one is obviously Joe Grant's class. I really wanted to take it here at DerbyCon. I didn't get the chance. It was sold out fast, but maybe next year I'll get to take it. A couple of blogs that are really great. There's Craig Hefner's blog. If you're doing anything with like SOHO routers, you'll probably come across that one. And then Don't Stuff Beans Up Your Nose is Stephen Ridley's blog as well. You'll find some of his material there. And so, I don't know, I hope that maybe you'll be able to take some of this material and it'll give you the ideas, the tools that you need, and kind of encourage you to go out and do research on these devices, because there's so much out there to play around with, and all of these IoT vendors or people bringing devices to market, they're just hauling ass to get their product out there. So they aren't thinking about security much at all. And so I think that it's definitely up to us as the security community to at least get these devices into a better state than where they're at now. So I hope that the material here has been useful, and you can do it too. It's fun. And that's pretty much what I have for you. Yeah, I just wanted to say thank you to the DerbyCon staff, other researchers out there like you guys. I totally would not have been able to learn some of this stuff without you. So, and if you're interested in getting in touch or whatever, check out securityevaluators.com. The GitHub link there, I've started collecting a bunch of firmware and posting it up on GitHub, so you can check that out. Check out my Twitter, and I think that's about it. So thanks, guys. Are there any questions, I guess? Yeah, I can answer questions, yeah. Yeah, so the question was where to find different data sheets. I mean, for the most part, what I'll just do is throw stuff into Google. There are a couple of websites, I think datasheets.ru. A lot of the Russians have really extensive collections of data sheets for whatever reason. They actually repair their hardware, so I'll find some of the stuff on shady Russian sites. So it's not uncommon that I'll find them there. Any other? All right, sweet. Oh, what's up? Oh yeah, definitely. That is actually another great resource. The FCC's website, if you have a device and you can figure out the FCC ID, there's great, internal photos, external photos, some of the the RF testing and stuff like that. Yep, that's definitely a good resource. Cool.